Right, children, let us continue with the topic. See, we have discussed different types of functions. Now, before function, first we try to define what is the relation. Right, from relation, we have deduced a function. Then in function, we have seen domain, codomain, image, pre-image, definitions. We made use of them when we were looking into the proof of the theorems. Injection, that is one function. Surjection, that is an onto function. And then we were just entering the concept bijective function. Now, before we go to the theorem, the next theorem, let us try to brush up the things what all we have discussed, children. A relation F maps A to B, right? We have never taken any condition on that. Like we have taken a subset of cross product, isn't it? The Cartesian product of two sets. Now we have taken two sets. From the first set, we have taken all the elements and we have ensured that they are related to every element in set B. All right. Then we said that it is a Cartesian product. Now, in that Cartesian product, any subset or the total of A cross B, if you take, then we called it as a relation. Now, over the relation, if you are imposing certain condition, then you are getting the definition of a function. What is a function? A function F maps A to B, isn't it? Before a function, it should be a relation. So relation becomes a function only when every element which is there in set A, that means the first set, it has got some image in set B. That means no element in set A will be left without any mapping. All right, children. So in that case, we will call it as a function. And the very important condition which you need to check here is one element cannot have two images. One element cannot have two images. That means now you are selecting one element in the first set. You cannot relate it to you cannot relate it to many elements in the second set. So one to many is not at all a function, but many to one can be a function. That means many elements can be related to one element which is there in set B. All right. So such type of function will come across when we move on to the topic in detail. All right. Now, after looking into what is a function, we have seen a one function. Every element in set A has got a distinct image in set B, right? Distinct, we have used the word distinct. Distinct means what, children? One element in the first set will have only one element as the pre-image. And for the second element, the same image will not be taken. So it will have a unique different value in set B. Therefore, in that case, we can call it as a one function. And when we talk of onto function, we said, see, we have seen two cases. One is the codomain and range of a given function. If they are equal, then we can say it is an onto function. Or otherwise, you can very well say that for every B belongs to B, there exists an element A belongs to A such that f of A is equal to B. All right. So one function means you will have distinct images for every element in the first set. Onto function means for every element in set B, you will have a pre-image in set A, right? So that f of A will be equal to B. Now coming to bijection, What is a bijection? Bijection is a combination of both. If a function satisfies 1, 1 and on two conditions, then we can call it as a bijective function, right? As we have seen, when two functions are related, right, by some condition, right? So we called it as a composite function. F and G are two functions, then F maps A to B and G maps B to C. These two are any two functions. Then if you are picking an element from set A, then its image will be in B, which we call it as F of A. That F of A is nothing but B. That F of A, if you are again substituting in the function G, then you are getting a G of F of A. All right. So G of F of A, which is nothing but the composite function of G with F, we will represent it as G circle F of A, which are getting it as equal to C. All right. Now we have seen if you have any two functions which are 1, 1 functions, then the composite G circle F maps A to C is also a 1, 1 function. Not only that, we have seen you are given with two surjective functions, that is two onto functions, then G circle F maps A to C, that means the composite function also will be a surjection, also it will be an onto function. Now the next theorem which follows the two theorems what I was mentioning just now is the theorem Madam, is the screen visible?
No, madam.
Right. Now let us look into the theorem, children. Right. Now F maps A to B and G maps B to C are any two bijections. Then G circle F maps A to C is also a bijection. Right? This is what is the theorem. Now let us look into the proof, children. What is that you are given with? You are given with F maps A to B is a bijection. What do you mean by a bijection? Just now I was mentioning it should be a 1, 1 function. It should be an onto function, right? Now for 1, 1 function, what is that we have seen as a condition? If you take any two elements, from set A, right? And if you are getting the images as F of A1 and F of A2, if the elements are A1 and A2, if the images happen to be equal, it means that the elements also should be equal. This is what is the condition what we have seen. So for A1 comma A2 belongs to A and F of A1 is equal to A2. Why is it so? Because it is a 1, 1 function. F is a 1, 1 function. Now, if already we said F is a bijection, so it should be onto also. So if it is an onto function, for every element in set B, there exists a pre-image in set A, isn't it? So we will define it like this. And for B belongs to B, there exists A belongs to A such that F of A is equal to B. This is the condition what we have for an onto function. Since F is an onto function, we can always write this statement. So these two are very, very important deductions from this word bijection, isn't it? Bijection is telling you that F is 1, 1 and also onto. That means the function F is satisfying both the conditions. Not only this, children, you are given with function g also, which is a bijection. So G is 1, 1, G is onto. All right. So you are given G maps B to C is a bijection. That means when you select two elements from set B, if the images of those two elements are equal, it means that the elements are also equal, right? So for B1 comma B2 belongs to B and G of B1 is equal to G of B2, it implies B1 is equal to B2. Why so? Because G is a 1, 1 function. All right. Then G is also onto. So for C belongs to C, there exists B belongs to B such that G of B is equal to C. Why? Because G is an onto function. All right. So let us consider G circle f of A1 is equal to G circle f of A2. Then it implies what? G of f of A1 is equal to G of f of A2 by the definition of the composite function. All right. Then you are given that G is 1, 1. So it implies what? G of f of A1 is equal to G of f of A2. So this implies f of A1 is equal to f of A2. Since G is 1, 1, you are getting this condition, children. So instead of this G of f of A1 equal to G of f of A2, we can always write it implies f of A1 is equal to f of A2. Not only this, you are given that f is 1, 1. If f is 1, 1 and f of A1 is equal to f of A2, it implies A1 is equal to A2. So since f is a 1, 1 function, you can always replace this, or this is also equal to A1 is equal to A2. Therefore, we can say G circle F maps A to C is a 1, 1 function. So let us see this in the diagrammatic form. You have a set A. A1 and A2 are two elements in this set. You also have a set B, right? Over these two sets, you are defining a function F. Now, in this function F, if you are substituting A1, then you are getting it as F of A1. And when A2 is substituted in function F, you are getting it as F of A2. Then G is a function which is defined on B and C. All right. So let us take the set C. So from B to C, the function is G, right? When you substitute f of A1 in G, you are getting G of f of A1. And likewise, you will be getting G of f of A2 when f of A2 is substituted in the function G, right? So therefore, we can say G circle F maps A to C is 1, 1 function. Now let us consider C is equal to G of B. But what is B, children? B is nothing but f of A. Now, what is G of f of A? It is nothing but G circle f of A. So G circle f of A is equal to C. This is what you are getting. Now let us see the representation of this in the form of a circle. Now in the form of a diagram, you have a set A with element A and set B with element B, over which a function f is defined. Then in f, if you are substituting A, then you will get it as f of A. So B is equal to f of A. B is equal to f of A. All right. Then you have set C, right? Now a function G is defined on B and C. Then when you're substituting f of A in B or f of A in G, or you can say you're substituting B in G, right? Then you will get it as C. But what is this C equal to? G of B. What is G of B? Again, it is related as G of f of A, which is equal to C. All right. So G circle f of A is equal to C. This is what you are getting. Therefore, for every C belongs to C, there exists A belongs to A such that G circle f of A is equal to C. Now, what is this condition telling you? It is telling that G circle F maps A to C is a surjection, right? Now, we have proved that G circle F maps A to C is 1, 1. G circle F maps A to C is a surjection or an onto function. So, if it is 1, 1 and onto, then it is a bijective function. Therefore, we can conclude saying that G circle F maps A to C is a bijection. Hope the theorem is clear. Actually, this theorem, what you are seeing right now, is a combination of the previous two theorems. Okay, if you are good at those concepts, then just putting them as two parts will be giving you the proof of this theorem. Right. Now, quickly we will look into a problem. If the function f is defined by f of x is equal to x plus 2 for all x greater than 1. Now see the condition what you have, children. This is an important one. See, you have three conditions. When for different conditions, the function is taking different value. All right. Now, if you take x greater than 1, then f of x will be x plus 2. When your value of x is lying between -1 and 1, then the function f of x is equal to 2. And likewise, when x is lying between -3 and -1, then f of x will be equal to x minus 1. This is the meaning of the statement, children. If you understand the meaning, solving the problem is not at all difficult. So you need to check for such type of problems, you need to check the condition, then try to take the function which is applicable for that particular value of x. Okay. Now, if the function f is defined like this, then find the values of f of 2 plus f of minus 2. F of 2 plus f of minus 2. All right. Now we will look into the solution. F of 2 is equal to 2 plus 2. Why it is 2 plus 2? We will look into this. Now, when I say the value as 2, how is the value? The value is greater than 1. That means the function f of x will take the functional value is x plus 2. F of x will be x plus 2 because x value, that is 2, is greater than 1. All right. Now, when you take this as your function, instead of x, you're substituting it as 2. So 2 plus 2 gives you 4. Now, suppose if you're taking f of minus 2, minus 2 is falling in this interval, isn't it? So f of x should be x minus 1 when you are taking this value, that is f of minus 2. So f of minus 2 is equal to minus 2 minus 1. Since f of x is equal to x minus 1, when your x value lies between -3 and -1. Now look at this, children. Instead of x, you are substituting -2. So -2 minus 1 gives you -3. Right? But what is that he is asking in the question? F of 2 plus f of -2. So therefore, f2 plus f of -2 is equal to 4 plus of -3, which is equal to 1. Hope this is clear. Right. Now, this is the function which is given to us, which is defined in this way, right? Now, we will take the next bit, f of minus 1.5. Now, just observe where this minus 1.5 lies, in which interval. Now, minus 1.5 is not greater than 1. Minus 1.5 will not come in this interval. So, it should be only in between -3 and -1, right? So therefore, f of minus 1.5 is equal to minus 1.5 minus 1. Why so? Because your function is f of x is equal to x minus 1, because your x value is minus 1.5. Okay, so minus 1.5 is replacing x in this. So you're getting minus 1.5 minus 1, which is nothing but minus 2.5. Right? Now, the next bit what I would like to take is f of minus 5. Now, can you people just tell me where this minus 5 lies, in which interval? Can you please check and tell me? Hope you found somewhere. No? Yes, you are right. It is not at all defined, children. You are not given with a condition where minus 5 can be fit into the function. Therefore, we can conclude saying f of minus 5 is not defined. F of minus 5 is not defined. All right. Now we will go with the next problem. If a is equal to 0, pi by 6, pi by 4, pi by 3, and pi by 2, and f maps a to b is a surjection. Surjection, it means it is an onto function, right? Defined by f of x is equal to cos x. Then find b. This is what is your problem. Before we see the solution, just we'll try to analyze what are these values. See, you are familiar with the trigonometric terms or the trigonometric ratios, what you have seen. We have 6 trigonometric ratios, isn't it? Sine, cos, tan, cot, secant, and cosecant. Right? You have also learned the standard values of these functions, these trigonometric ratios in your class 10th. Right? That is 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. You are familiar with these values, isn't it? So let us see what are the values which are given in set A. 0. Here pi stands for 180 degrees. We will discuss this in detail when we take up a trigonometry topic. But as of now, you can take it for granted that pi is equal to 180 degrees. Now, if it is 180 by 6, this is 30. 180 by 4, it means 45 degrees. 180 by 3, this is 60 degrees. And 180 by 2, this is 90 degrees. Now, in set A, you have 0, 30, 45, 60, and 90 degrees measures. And you are given that f is a function from set A to set B. Now, what is there in set B, we don't know. We need to find out. All right. Now, how is that you will find out? You will find out making use of this function. F of x is equal to cos x. Right. Now, you are given that f maps A to B is a surjection. Shall we have a repetition of the definition of a surjection? Surjection, it means every element in the second set will have a pre-image in the first set. Okay, for every B belongs to B, there exists an element A belongs to A such that f of A is equal to B, right? Now you are also given that f of x is equal to cos x. Now, what is that you are going to do to find the set B? You will just take these values, substitute in the place of x, and get the value of this function. And what all values you are getting, they are nothing but images, isn't it? So those images put together will give you the set B. All right. Now f of 0 is equal to cos 0. What is cos 0? Cos 0 is 1. Now likewise, f of pi by 6 is equal to cos pi by 6, which is equal to root 3 by 2. Right? Now f of x is equal to cos x, right? Now we'll go for the remaining substitutions. F of pi by 4 is equal to cos pi by 4. Cos pi by 4 is equal to 1 by root 2. Hope you are recollecting all the values of the trigonometric ratios, isn't it? Right. F of pi by 3 is equal to cos pi by 3. Cos 60 degrees is half. Next, f of pi by 2, which is cos pi by 2, that is cos 90 degrees, is equal to 0. So what are the values you have got, children? You have got 1, you have got 1, and then root 3 by 2, then 1 by root 2, then 1 by 2, and 0. What are all these values? These are images of the given elements which are there in set A. So all these images put together will give you set B. And since it is a surjection, we have already seen the codomain will be equal to the range. So therefore, set B is equal to 1, root 3 by 2, 1 by root 2, 1 by 2, and 0. Next, we'll see another question. If A is equal to -2, -1, 0, 1, 2. This is a set A. And you are given with a function f maps A to B is a surjection. This is surjection again. And the function is defined as f of x is equal to x square plus x plus 1. Then you need to find the value of B. Okay, you are given that A is equal to -2, -1, 0, 1, 2 as the elements, and f maps A to B. Now you are also given that f of x is equal to x square plus x plus 1. So what is that you need to find out, children? You need to find the value, you need to find the elements in set B. How do you get those values? As we have seen in the previous problem, just substitute the values of A in the function and you get the images, right? So we will start doing it, children. F of -2 is equal to -2 whole square plus of -2 plus 1. So this is 2 minus 2 whole square is 4 minus 2. 4 minus 2 is 2 plus 1, which is equal to 3. Then f of -1 is equal to -1 whole square plus -1 plus 1. So here it is 1 minus 1. They get cancelled and you are left with 1. Then the next value, f of 0 is equal to 0 square plus 0 plus 1, which is nothing but 1. Then f of 1 is 1 square plus 1 plus 1, which is equal to 3. Then f of 2 is 2 square plus 2 plus 1, which is equal to 7. 2 square is 4 plus 2, 6 plus 1, 7. Right, children? Now just observe this. You have the functional values. You have the functional values as 31137. 31137. Now, children, you need to cast your mind a little back and recollect the topic sets. The condition when you write a set is no element in the set will be repeated. You are getting some values which are repeated, isn't it? What are those values which are repeated? 3 and 1. All right. So without repetition, we will write in set B. So therefore, B is equal to 3, 1, and 7. Or you can write it as 1, 3, and 7. It hardly matters. Okay. All right. Now the next topic, what we have is equality of functions. Equality, the word itself is telling you that there is something which is equated. And what is that you are equating here, and what are the things which are equal over here? We are just trying to define what is equality of functions. Functions, that means it should be more than one. The comparison comes only when you have more than one, right? Okay. Now, if f and g are two functions, then we can say the function f is equal to g if domain of f and domain of g are equal. Right? Domain of both the functions should be equal. That is the first condition. then f of x is equal to g of x for all x belongs to domain of f. Now, it means what? Domains are equal for both the functions. And when codomains are also equal, this f of x and g of x are also equal. Where do you find this f of x and g of x values? In the codomain. All right. Now, based on this, we will try to see one example. On what domain the functions f of x is equal to x square minus 2x and g of x is equal to minus x plus 6 are equal. Right? Now, if they are equal, for what domain, on what domain the functions will be equal? That is the condition. So we will start saying f of x is equal to g of x, and we will derive or we will try to find out what is the domain on which they are equal, right? So we will equate both of them, both the functions. That is x square minus 2x is equal to minus x plus 6. Right? So you will get it as x square minus x minus 6 equal to 0. How? This minus x, when it goes this side, it becomes plus x. So minus 2x plus x is minus x, and 6, when it moves this side, it becomes minus 6. All right. Now it is looking like a quadratic equation, which you have learned in your class 10th again. Right? The quadratic equation can be solved by different methods. Now, one method you have seen was formula method, and the other one factorization. I would like to take factorization right now. Okay, x square minus x minus 6 equal to 0 can be written as x square minus 3x plus 2x minus 6 is equal to 0. Right? So from the first two terms, you can take x common and you can write it as x minus 3. And from the last two terms, you can take 2 common and you will get it as x minus 3 equal to 0. Therefore, we can write it as x minus 3 into x plus 2 is equal to 0. Therefore, here you will be getting it as x minus 3 into x plus 2 is equal to 0. This means x takes the value as minus 2 and 3. Right? Therefore, we can conclude saying that f of x and g of x are equal on the domain minus 2 and 3. In the domain, when you have minus 2 and 3 as the values, then they will be equal. Then the two given functions will be equal. Now, the next definition is another type of function, that is identity function. Right? Identity function. Okay. F maps A to A. Can you see any difference between the previous definition of function f and this? Yes, you are taking the same sets as domain and codomain. Please observe this, right? A function f maps A to A defined by f of x is equal to 0 for all x belongs to f of x is equal to x for all x belongs to A, then it is called as an identity function. And the identity function is on A. It is denoted with IA. It is denoted with IA. Now, what exactly is this? We will try to have an explanation for this, children, with a diagram. You have set A as your domain, and in this you are taking an element x. You have another set, this is also equal to A, the same set you are taking. Over this, you are defining an identity function. You can call it as an identity function when you substitute the value of x in this. If the output or the image what you are getting is again x, then we call it as an identity function. Now, generally we will call it as I, but here we are calling it as IA. The reason is you are defining the function on set A. If you are defining it on set B, then you will call it as IB, and so on. Hope the definition is clear. Then the constant function. Constant, the word itself says that it is something related with a constant. Okay, let us look into this. a function f maps A to B is said to be a constant function if you have f of x is equal to C for all x belongs to A. That means whatever value you substitute in the place of x, you will get the same answer as C. Okay, so this is this we can call it as many to one function. I was mentioning, isn't it? When I was discussing many to one relation, it can become a function only when, I repeat once again, every element in set A have a mapping in set B. Compulsory. No element in set A is left without any mapping. No element in set A should be left without any mapping. Okay, we will see the diagrammatic representation for this. Now you have set A with ABC as elements. Set B has got only one element here, children, that is 1. That means I am substituting A in function F, then you are getting it as 1. B, if you substitute, again you are getting 1. C, if you substitute, again you are getting 1. That means for all these elements, the image is same. So in this case, we call it as a constant function. Okay, one example on this constant function we will try to discuss. Now, if f of x is equal to cos square x plus sine power 4x by sine square x plus cos power 4x for all x belongs to R, then show that f of 2020 is equal to 1. Okay, before we look into the solution of the problem, again we will try to cast our mind a little back and try to recollect what exactly we have seen in trigonometry chapter in your class 10. We have seen identities. Hope you remember that, isn't it? Sine square x plus cos square x is equal to 1 is one of the identities which we have learned in our class 10. So when we have cos square x plus sine square x is equal to 1, we can always write sine square x is equal to 1 minus cos square x, or we can also write cos square x is equal to 1 minus sine square x. The same concept we are trying to use in this problem. All right. Now you are given that f of x is equal to cos square x plus sine power 4x by sine square x plus cos power 4x. Now, in the numerator, instead of cos square x, we will replace it with 1 minus sine square x, as I was discussing right now. Right. So 1 minus sine square x plus sine power 4x. Now, likewise, in the denominator, instead of sine square x, we will replace it with 1 minus cos square x. So you're getting it as 1 minus cos square x plus cos power 4x. Now, in the numerator, from these two terms, the last two terms here in the numerator, we will take sine square x common. Then you will get it as 1 minus sine square x into 1 minus sine square x. Likewise, in the denominator also, from these two terms, we will try to take cos square x common. So you will get it as 1 minus cos square x into 1 minus cos square x. Now, children, what is 1 minus sine square x? 1 minus sine square x is cos square x. Then what is 1 minus cos square x? It is sine square x. So we will try to replace the same in the next step. So you will have it as f of x is equal to 1 minus sine square x into cos square x by 1 minus cos square x into sine square x. If you can observe carefully, your numerator and denominator both are same. So we can cancel numerator as well as denominator. Then it will give you f of x is equal to 1. Right? F of x is equal to 1 is your function. Okay. Then what is your question? Did he ask you to write what is f of x? No. He's asking you to write f of 2020. Okay. So instead of x, we need to substitute 2020. Just substitute and see whether you substitute 2020 or 2019 or 100 or 1000, whatever it is, your answer remains only 1. So therefore, f of 2020 is equal to 1. So we can conclude saying that the given problem is representing a constant function. It is representing a constant function. Now, practice questions. As I have given this already, you can take a screenshot, children. Now, these are all composite functions. We have already seen an example, right? So, F circle G is F circle G of Y. How do you write it? F of G of Y. If it is G circle F, then you will get G of F of X or G of F of Y. Now here in the second problem, the function is defined in terms of Y. The function is defined in terms of Y. So he's mentioning Y over here. So you will take left hand side first. You get the value of F of G of Y. Then you just check whether it is equal to Y or not. If it is equal to Y, then you say the statement what he has given is satisfied. Okay. Then the third problem, it is similar to the problem what we have seen. Now in the first case, F of G of X you will calculate. Second, it will be G of F of X. Here F of 0. Directly you can substitute and get F of 0. F of 0 when you calculate, instead of X in this function, you will just replace it with 0 and you will calculate the problem, right? Here it is G of F of 3. That means G of F of 3. First you calculate F of 3. That F of 3 value, what you are getting, again you will substitute in the function. Then the value what you're getting, you will substitute in G and you will finally end up with the answer required. Now, likewise, all the problems are same, but I would like to take up this problem 5 also. Just look at this. Don't get scared when you see root x. Root x remains root x only, right? Now, G circle F of x. So G of F of x. G of F of x is what? G of 1 by x. So in G, wherever you have x, you substitute 1 by x. So what is that you will get? G of 1 by x will be root of 1 by x. And hope that you will complete these problems. In the seventh problem, you have three different functions. Did you observe? Right? This is F circle, G circle, H. The same concept continues, children, but a little lengthy, that's all. It will be F of G of H of X. First, you will take what is H of X. Then answer what you're getting will be substituted in G. Then that value, after substituting in G, the answer what you are getting will be again substituted in F. Then finally, you will land up with the required answer. Hope that you will try. I hope you have followed all the clearly. Now, your mind, please keep practicing. Madam.
Thank you, Usha madam. Thank you for such a wonderful session. And you have again explained all those concepts clearly. And I hope students have made a note of it and they'll get benefited. Students, you can revisit both the sessions of functions that are covered today. And again, practice the questions that madam has given you. And also go through the textbook. Try to solve some more problems. Happy learning, children. We'll meet again with another interesting session. Thank you, Usha madam.
Thank you, ma'am. Thank you.